A part in conference, including you.
Are text-based than numeric-based. So I mentioned the Pareto chart, but the other case is also the clock diagram. So go 1 second to say you more than one way to skin a cat in Minitab. All right, just for example, look at his histogram. There's multiple ways to do it. And just go into Graph, click on Histogram, Stats, the graphical summary, Capability Analysis. Capability Analysis gives you a with some other analysis. Under heading, Histogram is under there. Under Define, the graphical summary is there. Measure, graphical tools. On the Assistant, graphical analysis and histogram. All sorts of different places generate. In fact, I was going to say, okay, if we were to generate a histogram for that 160-degree hair dip, that outlier in there, this is what the histogram would look like. You know, we've got that number way out there at like 2,600, or whatever that particular was. The rest, when we eliminate that single outlier, this histogram looks like afterward. If we were to backlog delay causes, all right, again, in the worksheet, is where is my causes? All right, test log. Testing backlog worksheet. If you take a table that the individual causes and the number of cases a particular cause, or we got a full column of different backlog causes. Analysis in a couple different places. So under SAT, quality tools, and your Pareto chart. The other place is under Define on the MAIC roadmap. So here it has the individual attribute characteristic. Now, guys call out defects, and from the tire industry, we don't like to use the word defect because negative connotation associated with it. We would have abnormality. I'm going to put test under defects. These are column, and then I would click OK. No. What doesn't here? That these my two favorite columns aren't of equal length. So there must be one here somewhere that I didn't. What? So I'm just going to delete. Right, let me try that. Pareto chart days. Click OK. All right. So completely unsuccessful in that little exercise. Sheet. I'm going to go put the backlog causes and do that Pareto chart. The test that does the biggest delay, the torque wear test. So based upon that information, the belt whose project this is from was a guy named Ben Galizio. He sent information and said, okay, he's got to do it, or he's going to revise this torque wear test tool backlog. So that's the project. One of the things that we would ask you to do when you're looking at this type of chart is to see in the title, right? Go ahead and list the time frame for the data that's contained in the chart. So I have Pareto backlog causes. To edit the title, all I've got to do is double click on it and December 2013. Click OK, and bing. Information and what the time frame of the data is. And as I said, it's very easy to change that title. Editing any graph is just that simple. Double click on the chart, and this comes up to change the fill pattern. Right now it's the default automatic. I'm going to give it background color, and I'm just going to give it some heat. Now, I might also double click on this guy again so that this guy's the only guy that's highlighted. Click. And notice the automatic fill for this spot. And I'm going to customize this guy. And this guy, well, I want yellow, bright yellow color, but that's the brightest yellow that they've got. Highlight him by using the yellow versus the rest of the crew. It'll be all green. If I want to, I can click on this background back here and change the color of the background. I can see axis here, change the scaling of the axis, or this axis down here. I will click on the text, change the font of the text if I wanted to. So, Minitab plot is very, very simple. And again, I'd like you guys to use Minitab and getting used to using it. It's really very easy to use. All right, now, hope I look back at this guy. This guy tells me what should have happened on that plot. Right? Test and days should have generated this plot for you. I don't know what is for a data set which isn't allowing you to generate that plot, or isn't allowing me to generate that plot anyway. And I wanted to the text of it. All I've got to do is click on it and then push it up. And backlog causes chart. Now, let me go over a second. All right, so backlog data in this chart. Let's look at causes too. Click OK. Notice in the first chart and second chart. Side by side, I'm going to use this critter. I'm going to go up to Tools for a second. And we go to Editor. Tool. The left tool allows me to use a couple different, or put a couple different charts up in time. And I'm going to use the Pareto chart about causes, the other one that I had. And I have 2 rows, 1 column. Why did it do that? All right, so I've backlog causes 2 and the backlog causes. I've got those laid out, and I click on Finish. So now I have these guys on the same plot. And if I take a look, In my original plot, torque wear was the first variable. It was the first major cause. Notice down here, we've got torque wear here and here. Mine two of them. These are capitalized. Mini is case sensitive. Back at my original data set. Alright, look down backlog causes. Alright, guys with capitals, and then to these guys, all smalls. Smalls. Makes it in the output on that Pareto analysis. So be again, one of the reasons why we would go through this, and in fact, you could have just done a histogram based on the effect causes, or here, even the Pareto allows me to take a look at all the different causes. And I can see the difference in the text between alls and torque wear being capitalized. Again, make sure and check your data. Some other weeks we can talk about some process testing, analysis of variance. I mentioned confidence intervals before. We've got some other statistics. Some of those basic tests I mentioned under the basic stats. The one sample t-test, two sample t-test. Your out there is pretty much in a little table or output on the session window. Well, a couple of examples there. So we'll go it through though. All right. The tool that I want to use in Minitab is going to be the assistant to take you through those other couple of examples. So the assistant is the new critter that they added to Minitab 16. And if you last week when we started to talk about the product, Ira mentioned that we have 17 that's been released. Now the class is just being Minitab 16. The difference between 16 and 17. Added functionality here in the assistant. 17 is the assistant for experimental design or design of experiments, typical DOE. So to show you here for the assistant, there's no difference between 6 and 17. So we'll do a couple of examples and then see if you guys have any questions. And thinking behind the assistant was that it would be kind of a or flow diagram based approach to statistical analysis. So what they said that historically you can practice this about anybody going through a stats class. All right. What tool do you use? All right. I can say when I was going through Stats 101, it was difficult to figure out how many steps I should go through if I just wanted to find the difference between two averages. I'm not sure if I was supposed to use, a sample T or how I should do it. Right? As you class, as you Six Sigma thing, all right, we'll go through the methodology, talking about the normality, capability steps for handling capability. we'll talk about stability, normality, evaluate the variations, and then calculate your hypothesis test. All right, got it pretty much down to a set of steps. So take away some of the heartburn or anxiety of applying some of these techniques in Minitab. When all else fails, I can fall back on the assistant. And hypothesis testing is one of the biggest areas that Minitab help out in, like I said, reducing the anxiety of having to actually do the test. So when we look at it, the ideal for the green belts, or really anybody that's new to statistics, it's like this here, the most commonly used tools, or as in 16 does, and like I mentioned, in 10 they rolled it over to DOE. And like I mentioned, the decision trees help you to choose the right tools. The other is detailed reports results. So a long way in helping you explain to, say, manager or whoever it is that you want to present your results to, exactly what the results mean. And so there in the bottom point, make analysis easier and safer. Safer from the perspective of the reduced probability of making a mistake, which could create issues in, say, once a product been used or that has been developed using Minitab, once it's released out in the field. Something bad happens, you might say. So, hypothesis test. All right, for a food manufacturer, you need to make sure that the weight of a certain product is equal to 140 grams. All right, sample 90 items, measure the weight of each item. All right, this is typical. All right, I'm in the kickoff that I worked for PPG at one point in time. We paint cans, and our paint can had a weight on it, or a volume. All right, we make sure that to meet land, that containers actually had the amount that the container said it held. And say, in this case, the food manufacturer, they had the same issue that we had. Challenge. How do you guarantee that my container says 140 grams, that it's actually 140 grams in it? All right. In this particular case, they randomly sampled 90 items. All right. So it becomes what I use under assistant. So we start with hypothesis testing and get my choices under hypothesis testing. I compare one sample with a target, compare samples with each other, or compare them two samples. Well, here, weight, grams, and I've got just a single sample. Now, the sample might be made up of 90 items, but it's still just a single sample. Compare it, that's the run to go down. So if we were to jump over and look at my data sets again, work this test, and the one that I went ahead and plowed that data on, or created that cyclical data set, I've got string in there. So scroll down, you can see the 90 data points. Scroll up. We said come down assistant. My choice of these three. And we said come sample with a target, goes down. One. I look at All right, continuous data or attribute data. Well, our data is continuous. It's weights and compared. Do we want to compare the standard deviation versus a target? We want to compare an average versus a target. In our case, back to I want to make average weight 90 samples is 140 grams. All right, the weight versus a target. Go ahead and clicked on that guy and asked me, okay, where? Well, my didn't weight. My target value was the 140. Comes the difficult question. What do I ask if the weight is greater than 140, 40, or different than 140? Now, we turn around and say, well, if I'm trying to protect the customer, I want to pick the second one. Then the weight is less than 140. Because if it's less than 140, then I got the consumer protection group jump over me. From his and then across, I'll go back and say all industries actually. The one that surprised me the most was the medical industry. These guys do studies for the ability to improve or determine the performance of a drug, all right, treatment. Guys look for is a difference. They don't question, do patients get better or do they get worse? All right, specifically better or worse. They have better or worse. All right, different than 140. This guy up. The alpha, all right, default case, alpha error. All right, the making a mistake in this decision. That's 0.05. All right. Then back to that idea, the 95% confidence interval that I mentioned earlier. So that 9% confidence is kind of the complement of this alpha value, 0.05. So if I take 95, add 5, that gives me 100%. So that is rolled together. Now I can hear, I wanted to answer the question, do I practical differences? Meaning that, if I can't, or I have the ability to weigh to say, a gram for whatever reason, right? That value less than 1/4 gram, it came out to be 140.12, 1/4 gram. Anything less than that 1/4 gram, that's the difference from a engineering or a common sense standpoint. I tell you that I would say actually makes a difference in how I interpret the data. Again, I'll go back and talk about the medical industry. Talking about probably tracking cancer from cigarettes, drinking too much coffee, drinking too much coffee and eating bananas at the same time. Funky. Give you some ridiculous ability, like if you drink coffee, smoke cigarettes, and eat bananas all in a meal, probability of contracting cancer is 0.01% higher than the normal population. All right. Does 0.01% actually make an impact? talking about as far as this practical is. So I'm just going to leave it blank. I'm just going to click OK. Answer, and you see we've got three outputs. All right. The output is the report card that outlying data. All right, we point number 50. It's unusual compared to the others. Okay, put that in your back pocket. All right, normal and sample size is large enough. Go through. I want to say week 2. We talk about sample size. About size calculated average and standard deviation and believe in the result. The sample size should be 30. 90, so we get a nice little check mark there. Here we test for mean of weight diagnostic report, check whether or not the data is stable. This guy's an outlier, so I feel pretty good about my data being stable, but 58 kind of gives me a little heartburn. And then lastly, is there 40, 3. So here, and I'm hovering, and it gives us a little block of text to go ahead and read to better understand alpha means. Here, summary values, my sample size 90, the average 145, 90% confidence of the interval, or excuse me, 95% confidence interval of the mean, 155 to 150.47, standard deviation 23, target 140. If you look, the confidence interval does cover the value of 140. Confidence interval covered 140. Significant difference. Here on this table, here's my confidence interval of the average. We looked at the summary, and if I told you that the average wasn't on the same scale as gram on that graphical summary. In this particular case, this little confidence interval here is on the same scale as histogram. You can see that the interval goes from 140.55 to 150.46, and it doesn't cover 140. So that you to conclude that yes, this guy's supposed to be. Why isn't it? I'll get over it. Mean difference, or actually a mean difference between the target 140 and my process the way it's running right now, which averages 145.51. So, in this case, we saw a quick little recap of hypothesis testing. Quick little for control charts. All right. Use control charts to either evaluate the stability of a process or to see the average performance of the process and how stable it is. So we've got both characteristics. We've got a component of something that we look at for the control chart and also evaluate the variability. Here, for this particular case, we've got 5 inspection lanes and 1 passenger from each lane every hour. Control charts. So go up to my list of data sets. I'm into and one assistant. Go down to control charts. Again, the question is: my continuous is it attribute? Is it continuous? Is it? No, it's not, because I've got just a random sample of one person being pulled from the process. Sometimes this individual moving range chart. Click on it. It says, okay, what's my data column? Minutes. And I determine the control limits. There use the data. I've got some other known value I can plug it in. In this particular case, we'll just go ahead and estimate it from the data. And we click that. Right, may come back and said, hey, some data points that are out of control. Your limits should be calculated based upon a stable process. Control, you should identify the special causes. All right, go back and think about the case that I mentioned with that outlier, that nasty outlier at 2,921, or 2,921, which was 292.1. All right, I find the root cause. I omitted from the calculation, but instead I just fix data. If you omit a point, it's excluded calculation for both charts, both the individual and the moving range chart. I'm going in there. I'm just going to click OK. OK. It asks for data fails in normality test. You may see an increased number of false alarms. It says transformation. Do I want data? Sure, I'll say yes. And so back to the report card. Pass a normality test. Process mean and variation may not be stable. Okay, because we got the out of control points. Got another data. All right. It says correlated. We can see a number of false alarms because it's correlated. Oh, got this out here. And at table, we see the control chart for the average. No outside the control limit. Mean is stable. Moving well. So it says that investigate control points. Right. Realizes in this particular case, this really points out what is with I'll say most of statistics. The question here is process mean stable? Over time is whether or not we should focus fully on the mean, also fully hard on the variability of the process. For two, we focused only on the average of the process and have left the range of the variability to go wherever it wanted. One of the big challenges with Six Sigma is the variability of the best. All right, so for a call center, I want to evaluate the amount of time customers have put on hold. Customers wait longer than 10 minutes. They're going to cut the upper specification limit. We use 125 calls and measure hold time for each call. All right, so in this analysis will be that we go to. I've got my terms. So, quick key here. I think. Go to state. Under quality analysis. No. I'm going to select 1. Subgroup size of 1. And my upper spec, I'm going to call 10. Under, cancel that. Under options. This within subgroup analysis right here. All right. Options, unclick this guy. Here's my ability compared to. It says my PK number is 0.1. All right, that's capability. That's greater than 1, ideally greater than 1.33. So say, yeah, I wish it could be better. Down here, it kind of tells me where I'm outside the specification. Got my 6 up here. So that's a capability analysis. Guess I bruised it. I was supposed to back to the assistant. My bad. I have it. All right, here I'm building analysis. Again, question becomes under assistant, looking to determine capability or do before and after situation. All right, I'm going to determine capability. My data type, continuous versus attribute. I'm going to come here to capability analysis. Type analysis complete versus snapshot. All right, it says here use only with individual data that aren't in time order. All right, one column. We said group size 1, no low spec, upper spec 10, and then a target for the process. I could plug it in there. I'm going to go ahead and click OK. Here. My analysis, character process, summary statistics, verifying stability, not verifying that the data is normally distributed. So here, my normality test, my Anderson-Darling, it says p-value 328. It says less than 0.05, it would flunk. Is the probable. All right. Based upon this, like I said, I'd like to be up here versus down here. Okay, 0.61. I might have a value at least 1, better than 1.33. My z-score, all right, I score to be at least 2. Right, percent 31, and my ppm. So results for the capability analysis. All right. Lastly, a regression example for this guy is used to predict weights, height and weight. Want to explore the relationship between two variables, and best model that describes the data. Right. If I jump into the data, I've got X and a Y. On the back of the information that I should follow by guidelines, I'm going to click OK. And here, I've just got X and Y, so my weight is my Y, weight is my X. Next, there's a time element included to see if there's some correlation there. In other case, I don't know, so I'm just going to leave it blank. Notice, in that simple linear case, we had to calculate linear, quadratic, or cubic. Minitab, choose that, click OK. and their results shoot by. So as far as the question goes, the amount of data is small, in this case 20. Like I mentioned before, 30 is a nice good number, but here it says they like 40. Right? Unusual, hey, we've got a couple data points that have large residuals, unusual numbers, data with an unusual x value, so income higher. Points I don't need to worry about normality. And then gives you this and to be careful about what you want to do with your data. That range of x's, if it's properly over the entire range of the values that you've collected, and if here's the so if we were to look across it, so it actually brought in a model that had an x squared term. Didn't bother with a cubic term. Here's the correct term, here's the linear term. So to do the different sets of p-values. Here to here. Down there. Here, residue, unequal variation, this wedge test we'll talk about, clusters, curvature, large residual, a couple outliers out there. So here's us, we've got this nasty outlier up here and down here. You might say that, hey, there might be a little bit of a wedge pattern in here. As my values get larger, the probability or the difference between the actual predicted value or the predicted value gets larger. It's caused by these two individual outliers. Otherwise, the pattern is kind of straight. That's let's see. All right, so the last plot of that set. Is there an x and y? Value equals 0, 0, 0. There's a relationship. Again, it becomes, is that a causal relationship? We can only say there is a strong relationship between the x and y. All right. One plot that we haven't seen yet. I want to go ahead and do that plot right now. And that's the cause and effect diagram. So to wrap up class, I'm going to just come here to the C&E diagram. All right, data set. You see here are the topics or the major in your diagram. Mean, method, and material. Now, you don't have to use these. Go ahead and use them. All right. Actually, the items from the example for the testing backlog, look at these, the two are looking at test method that was causing the backlog, which we said was the, remember which it was? Let me look back real quick. The torque test. All right, the torque wear test, and okay, why is the test taking so long to do? So these are man, machine, method, and material items. If you notice, they're all text. And if I can do it, I can either come up here to my handy dandy little up here. Graphical tools. I've got my cause and effect diagram here. Under stat and quality tools, I've got my cause and effect diagram here. And you take a look at it. The labels that Minitab would use as personnel, machine, material, methods, measurement, environment. All right. I'll go ahead and highlight here. Causes that it will list under that. I'm just going to go ahead and click it in. Machine, under material, and under method. In fact, the effect is test delete. Title, I'm going to say is for test backlog. So I could add in subgroups. So I have something like multiple operators and with those guys down here. So I'm going to click on OK, generate that chart, and this is what it looks like. Now, let me go here, and as the last item that I'll do, suppose I add in a subtree here under man. In fact, multiple operators. Multiple operators here. Oops. The link that I'm going to tap on here, I'm just going to put in a few names. Joe. Walt and Nick. All right, so names. I'm going to go to this setup. Under heading, I'm going to put under multiple operators. Okay, and click again. This, I added in my sub-under multiple operators, my operators. So, and say we pretty much covered the whole techniques. These techniques that I had on here are left over are just repeats of techniques that we have already done. And if you guys just play around with this data, that's some hints as to do. So sim stocks pairwise, you might say, is if I look up here under basic stats, a p-test. Let's see. Information would just be simple ANOVA, normality test, what distributions, some quality control. So look at most of those guys, if you take at the data between the data set name or the data in the data set, you could, which particular technique to analyze it. Otherwise, it's just about any technique, just to take a look at the data, summarize the data as far as basic statistics are concerned, or just apply some graphical analysis to it. So, let me like I said, pretty much the gamut. We went from just basic graphs, basic descriptive statistics, and then got into a few of the more analytical, more sophisticated techniques also. I hope you a flavor for what Minitab could do. Any question? Are there any questions? Still out there?
I'm still out here, and it's a lot to absorb, and I'm sure I will have questions. This is Beth, by the way.
Not a problem.
Think of it at the moment. I'm still kind of digesting.
That's perfectly understandable. Say the only thing that we wanted to do was give you a quick overview of the breadth of what Minitab could do. You know, we keep the data set simple, keep the task simple. You know, so like I say, it's just hit the down, plug in a variable name, click OK, and so you got an output. And say try to minimize the search component. You know, but when you first started typing, you know, hunting and pecking on the keyboard, trying to figure out what letters you know how to find and where they were. Try a little bit simpler in Minitab. You know, stat and graph, most of the stuff that you want to do is located. And if you've got some higher order stuff like, you know, edit functions, the data functions, those off to the side, we still wanted to show it to you so that you get some idea of what Minitab could do for you. So yeah, questions, hesitate to ask. Send an email, give a call. Like good at turned on questions and problems. So, anything, Sherry? I'll turn it over to you if you've got any you want to say.
This is Jennifer. This presentation and video for it, will it be out on the SharePoint for?
Yeah.
That was sent to us previously.
Yeah, I'll put it there, and like I said, in fact, remind you guys of the link once I post them. Again, make sure that I can post them. I should be able to post them, and guarantee that I can. I'll send you guys an email, let you know exactly what the web is.
Okay, good, because I think I'm definitely going to have to go back to it to.
Sure. It's like there's a lot there.
Okay.
Yeah. Thank you guys for your time. Should check the schedule real quick just to see what we have coming up. And to say it was like this week. Yeah, next Tuesday the 25th. I'll touch points which is we want to review progress. Okay, you should at least have your 4 basic slides and then some. And then do it. With, like I say, unless anybody else has any questions, I'll dismiss. Working these things posted on SharePoint, and you got the specific website locations. Thanks a lot for participating. And again, if you guys have any questions, don't hesitate to call. Otherwise, we'll hear from you guys next Tuesday when we get together for the point.
I appreciate this. This is Anolka.
All right, thanks.
Yep.
Stop recording.